Okay, see Lindelof videos dividing mixed numbers. And this is actually pretty easy if you stay with me for a couple of minutes. This we can really work this out. It's very hard to do this division in the form it's in right now. And actually there's so much simpler way to do it. Let's just do that. The first thing we're going to do is we're going to convert these mixed numbers, this one here and this one right here, we're going to convert them into improper fractions. So if you remember how to do that, it's just in this case 2 times 2, and then we're going to add it to the numerator. So 2 times 2 is 4. 4 plus 1 is 5. So we get 5 here, right? We get 5 here. This fraction bar or solidus is this one, and this 2 is this one. So 5 halves is equivalent to 2 and 1 half. It's the same amount, just in different pieces, right? So here's our division side, and now let's work on this one. I'm going to do the same thing. I'm going to take 4 times 1 plus 3. 4 times 1 is 4, plus 3 is 7, so we have 7 fourths. All right? So we're not quite there yet. What we need to do is kind of one more little move to make this work really well for us. So what we're going to do is we are going to leave the first fraction the way it is. So I'm just going to make a little note that I'm moving all this stuff over here. So this 5 halves is this one, right? So I'm just going to do my work. And then I'm going to multiply. And you're like, Dr. Lindelof, well, why can you multiply when this says division? Well, that's a great question. And the answer is that we're going to change our math a little bit to make it work. And what we're going to do is we are going to take the reciprocal of this fraction. The reciprocal, to put it really plainly, is just that we're going to take this fraction and we're going to flip it upside down. So to flip it upside down, this 4 that's in the denominator right here, this white 4, comes up to the top. This fraction bar, solidus, right? This solidus, this one is this one, and this 7 that was at the top now goes to the bottom, right? Now we can turn this into multiplication instead of division. So I'm going to do that. And remember, when we multiply fractions, we multiply straight across. So 5 times 4 is 20, and 2 times 7 is 14. Okay, so that kind of stinks because we still have an improper fraction. We can simplify it a little bit. We can divide both of these numbers by 2, and 20 divided by 2 is 10. And 14 divided by 2 is 7. So that's an equivalent fraction that looks a little bit better, but still have an improper fraction. So what we have to do is a little division. So we're going to do 10 divided by 7, right? Every fraction, that's what its meaning is. It means the numerator divided by the denominator. So this is just normal math for us. So the question is, how many times does 7 go into 10 without going over the value of 10? And it happens to be one time, right? So 1 times 7 is 7. So this is just regular division, isn't it? 10 minus 7 is 3. So there's a lot of stuff happening here, but it's pretty straightforward, I think. This one right here is, we're going to make a mixed numeral. This one right here is this one, right? The 3, this orange 3 down here, which is our remainder, comes up to the numerator. Here's our solidus. And this 7, I'm going to turn it blue so we can see it. This 7 goes to the bottom. So our answer is 1 3/7. All right, let's try another one. This is actually going to be just fine. Let's keep working on this. All right, so think about how we just did the last problem. And we're going to do the same thing we did before. And that's the good news about this. It's the same procedure, the same method, the same steps over and over. So let's do this again. 4 times 1 is, let's be careful though, right? 4 times 1 is 4, right? And then 4 plus 3 is 7, so we have 7 fourths here, right? And then this fraction right here, here's my division sign. This fraction here is 8 times 4 is 32, right? 32 plus 3 is 35. So we have 35 over 8. You remember what we do next? Right? Because we don't want to do this division. We have to change this to multiplication. We have to do something first. And what we have to do first is take the reciprocal of the second fraction. And the reciprocal just means flip the fraction over. So that gives us, right? We're going to just write our problem over. 7 fourths times, instead of 35 eighths, we're going to have 8 35ths, aren't we? Okay, this is a horrible mess, but there's something that we can do here that we should look at. And when you have two fractions separated by a multiplication sign, you can cross cancel or simplify on diagonals. That is, we can look at these two numbers right here, the numerator of the first one and the denominator of the second one, and ask ourselves, what is their greatest common factor? And the greatest common factor of these two numbers is 7, isn't it? So here's our problem rewritten right here, right? So 7 goes into itself one time. How many times does 7 go into 35? It goes in 5 times, right? So now that we've done that, let's look the other way and see if there's anything we can take out of this. So we're looking at 4 and 8. So 4 goes, right? The greatest common factor of 4 and 8 is 4, right? 4 goes into itself once. 4 goes into 8 2 times, right? This is the end of our problem. It's actually going to work out really, really well, isn't it? We're going to do 1 times 2 is 2, and 1 times 5 is 2/5. All right, so this, as simply as we can do it, is how we do this. You know what, heck, let's do one more problem. I like this problem a lot. 9 divided by 2 and 4/7. The reason I like this is because it's a little bit weird. But think about this. I'm sure that your teachers have told you plenty of times that 5, any number, is itself over 1. So think of any number. Got your number? Yep, you chose 7. So 7 is the same as 7 over 1. Try another one. Think of a number. Right, 3. So 3 is equal to, oh my gosh, I can't believe I did that. This is also true, but it's not what I meant to tell you. 7 is the same as 7 over 1, so I apologize. 3 is the same as 3 over 1, right? So guess what 9 is? 9 is the same as 9 over 1. Good job. So we have 9 over 1 here, right? Divided by, we're going to do the same method we did before. Now we're going to convert this mixed numeral into an improper fraction. 7 times 2 is 14. 14 plus 4 is, right? 18. Golly, 18. Right? Going to keep it over 7. How are we doing? Pretty good, right? And now what are we going to do? Same thing we did before. We're going to take the reciprocal of the second fraction, and we know that reciprocal just means flip the fraction over. So I have 9 over 1. Right? We're going to change our division to multiplication, and instead of having 18 over 7, we're going to have 7 over 18. Same thing we did before. We're going to look at these two numbers, right? So 9 goes into, the greatest common factor of 9 and 18 is 9. So I'm going to just move it over here. So we're going to have 1 over 1 times 7 over 2. Is that right? I think that's right. Let's check my note. 7, right, is 7 over 2. Right, so, sorry, 7 over 2. And, oh gosh, the same thing we had to do before. We had to do a little division here. 7 divided by 2, right, is 3. 3 times 2 is 6. Just regular division. 7 minus 6 is 1. Let's talk about what this does again, right? I'm going to make a mixed numeral. This 3 at the top is this 3 right here. Remember that this 1 is our remainder, so it's remainder over, and this 2 right here is this 2 right here. So our answer is 3 1/2. Golly, that was kind of tough. So thanks for hanging in there with me. You did a great job. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do.